All right, good morning, folks. This is Mike coming at you with another video on Intro to Algebra. In the previous video, we talked about more properties of exponents, and we talked about the quotient rule or the quotient property for exponents. In this video, we're going to talk about a realistic application, or at least a more realistic application of those properties of exponents when we talk about scientific notation. For those of us who are going to go on to study more chemistry or physics, biology, just as some samples, those are all some areas where you're going to see a lot of scientific notation being used, and you'll want to understand what that means and how you work with those numbers that are in that format. So sometimes we find ourselves working with numbers that can be very large in absolute value. So those are large positive and large negative numbers, like say 520 million, or 2.7 billion, or negative 1.57 trillion, or something like that. You could also have numbers that are very small in absolute value, like 0.00000025 or negative 0.0000000001. And doing calculations with these very large or very small numbers, just not very fun to visualize, not really fun to actually write out and work with. So it can be easier to work with these numbers if we write them in a different notation. And that different notation is scientific notation. So if you have some number, I'll call it little a, we say that this little number a is in scientific notation if we can write it in the form some number c times 10 raised to some power n. Now, the exponent on 10, n, is going to be some integer. And c is going to be a number that in absolute value is greater than or equal to 1 and strictly less than 10. That is to say, c can be either be strictly greater than negative 10 and less than or equal to negative 1, or c can be greater than or equal to 1 and strictly less than 10. Basically, you only want one number to the left of the decimal place for c. Really, that's all this is saying. That's really the only thing you have to think of here for your c value. You just want a number so that there's only one digit to the left of your decimal place. And these are all samples of numbers that are written in scientific notation. 5.71 times 10 to the 5th power. 1.235 times 10 to the negative 7th. Each of these four cases, there is an exponent that is an integer, and our c value, the number before the multiplication, is a number that has one digit to the left of our decimal place, and that's it. So the big question is, how do we convert between scientific notation and the way that we typically write these numbers, like negative 0.00000001. And the phrase for how we write numbers as we typically do is referred to as decimal notation. So to convert from decimal notation to scientific notation, you're going to take the decimal point that's in the number, and you're going to move it so that there's only one non-zero digit to the left of your decimal place. The resulting number that you get is going to be the first part of your number written out in scientific notation. That is to say, this resulting number that you come up with after you move your decimal place, that's going to be your C value. Now, how do we figure out what the exponent is? The exponent on the 10 is equal to the number of places that the decimal was moved if the decimal was moved to the left. All right, if you took your decimal and moved it to the left, then the exponent on 10 is going to be equal to the number of places that you moved that decimal point. If you had to move your decimal point to the right, then the exponent on 10 is going to be the negative of the number of places that you moved your decimal point. So if you move your decimal point left, your exponent on 10 is going to be positive. If you move your decimal point right, your exponent on 10 is going to be negative. And the numerical part of it is going to be the number of decimal places that you moved. So let's do some sample problems here. First, we'll start off, this is 6,500,000. So I'm going to put my decimal point. This is a whole number, so I put the decimal point after the final digit of 0. And I'm going to move this decimal point so that there's only one non-zero digit to the left of it. So to do that, I have to move this left. So 1, 2, 3, 4, 5, 6. So I'm stopping, putting my decimal point right here. When I put it there, there is only one digit that is to the left of my decimal point. So the resulting number that I get when I visualize my decimal point here and not here is 6.50000, or just 6.5. So that 6.5, that's going to be the C value. That's going to be the first part of my number written in scientific notation. Now it's times 10 raised to some power. What is that power? Well, we moved the decimal point to the left, so we know that it's going to be a positive exponent. But what is the number going to be? It's the number of places that we moved our decimal. 1, 2, 3, 4, 5, 6. So 6.5 times 10 to the power of 6 is going to be this number in scientific notation. All right, let's go on to the next one here. Negative 0.0000000578. A lot of zeros going on there. All right, so again, we're going to take the decimal point and we're going to move it so that there's only one non-zero digit to the left of it. So I have to move it to here, because 5 will be the only non-zero digit that would be to the left of my decimal point. So that's where the decimal now goes. If you now look at this number that we have, pretending that the decimal point is here, I have a negative, because we have that minus sign up front, as 5.78. Times 10 raised to some power. What is that power? Well, first of all, we moved our decimal point to the right. So we know that our exponent is going to be negative. But what is the numerical piece of this? It's the number of places that I moved this decimal point to the right. And how many places did I move? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 10 to the power of negative 8. So that is this number written in scientific notation. I'll give you guys the small challenge of trying to figure out this one on your own, and we'll go through it in class. So that seems like kind of a lot in that process to go from decimal notation to scientific notation. Going the other way may not seem quite as bad. So how do we convert from scientific notation to decimal notation, the way that we typically write our numbers? You're going to take the first part of your number, that is to say, you're going to take that C value, and you're going to look at the exponent that you have on your 10. If the exponent is positive, you're going to take the decimal point in your C value, in that first part, and you're going to move it to the right by the number of places equal to that power. If the exponent is negative, you're going to take the decimal point and you're going to move it to the left by the number of places equal to the absolute value of that power. So if your power was, say, negative 6, you would move it to the left 6 places. So we'll do some samples here where we convert numbers to decimal notation. So first of all, negative 5.2 times 10 to the 5th power. All right, I'm going to take that number and I'm going to move the decimal. I'm moving it to the right because my exponent is positive, and I'm moving it to the right 5 places. So 1, 2, 3, 4, 5. And my decimal point is now going to be there. Now, I purposely left some spaces here, and I purposely drew it like this because you may think, okay, so you have a whole bunch of room here between this 2 and the decimal point. Okay, so what do I do? In each of these spaces where there doesn't seem to be anything there, we're going to put zeros. And now we can get a full number, and we visualize our decimal here. It is no longer here. So what is this number now? This is negative 520,000. So there is our decimal notation for this number. I'll let you try the second one on your own. It may seem very large. In fact, it is quite large, but nonetheless, it certainly still can be done. And it's not that complicated. It's not as bad as you may think. All right, 7.91 times 10 to the power of negative 8. Okay, so again, I'm going to take that first part. I'm going to take that C value. My exponent is negative, which means I'm going to move this to the left. And how many places am I moving it left by? The absolute value of your exponent, which would be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Decimal point is now going there. And again, we see the decimal point all the way over here. The rest of my number is there. You think, okay, what the heck? But we have to fill in zeros for these sort of missing blanks, these open spots here. So I have 0.00000000 0.000791. And that is this number in decimal notation. And I will let you try the fourth one on your own. I'll give you guys a little bit of a challenge here. If it's even a challenge, we'll go through these problems in class. All right, guys, so we'll pause here for now. In the next video, we will wrap up this section. And in the next video, we're going to be talking about multiplying and dividing numbers that are in scientific notation. If you have questions or comments, reach out to me, guys. As you know, email, in-person office visits, phone calls, telegrams, carrier pigeon messages, whatever form of communication you need. Until the next video, take it easy, guys.